This is 3.5 part 1, and we're going to talk about polynomials or trinomials of the form ax squared plus bx plus c, where a is 1. So basically we're going to look at questions that have an x squared with just a 1 in front, an x number with a number in front, and then just a c. And we're going to learn to factor those, which we did last section just using algebra tiles. And then later on, we're going to learn to multiply some binomials using algebra tiles and symbolic algebra. So again, what I'm talking about today, and this little blurb describes it, we're going to be given trinomials where the number in front of the x squared is just a 1. Now you notice it's not written there. If an x or an x squared doesn't have a number in front of it, we assume that there's a 1 there that you just don't see. We're going to call that number A. The number in front of the x is going to be called B, and the number by itself, which is always called the constant, is going to be called C. So we need to be able to identify which letter goes with which number. So review. This is from 3.4, the math lab that you did. You're given this trinomial, x squared plus 7x plus 10. And if we place those tiles in a rectangle, we can find the factors of the trinomial. Now remember, the factors that we actually referred to as the product or the length and the width in the last section. So to begin with, I'd like you to draw these tiles and I'd like you to draw them in a rectangle. And again, you may need to pause this video every now and again just to take the time to do it properly. But I'm just going to go ahead and I'm going to draw that rectangle. And in order for that rectangle to work, there's only one way you can position it properly. So there's the x squared tile. And if you play around with it for a bit, the only way that you can arrange the x tiles properly, 1, 2, 3, 4, 5, and try and draw them really well. If you need to use the plastic tiles, you can do that to see how they'll fit properly. You need to put the last 2 down here. And when you do that, you have enough space for exactly the 10 little ones that appear here. That's the only way you can arrange this. Now to find what we call the factors, we need to find the length and the width. And the length of this rectangle is how long you would have to walk if you walked from here all the way to the end. While walking from here to here is a distance of x. Then this is a distance of 1, 2, 3, 4, 5. X plus 5. Walking from here to here, again, from here to here is x plus 1 is x plus 2. Just a quick review. I know that this particular shape is called an x squared, and the reason it's called an x squared is because it is x wide and x high. So the edges have each a length of x in an x squared tile. What this means is the trinomial x squared plus 7x plus 10 can be factored, and that's an important word to remember, into the length and the width, which is x plus 5 and x plus 2. And that means that this original trinomial actually equals, in brackets, x plus 5, x plus 2. And our job today is going to be to turn trinomials with a 1 in front excuse me, into 2 separate sets of brackets, or what's called as factors. What I need to be able to do now is to take a look at this original question and tell me what A is, what B is, and what C is. Well, A is the number in front of the x squared, and it's 1. B is the number in front of the x, which is 7. And C is the number by itself, which is 10. Please don't forget that each term owns the sign in front of it. So this 10 is a plus 10. I didn't need to write the plus, but it is plus. This 7x is also a plus. If this would have been a minus sign here, then my value of B would have been a negative 7. Now the next part of this conversation kind of describes what happens up here. There's only one way to arrange this rectangle so that everything fits in there. And what really seems to be key is arranging our x's into 2 parts so that our 1 tiles fit. This is going to be like the first part of our arrangement and the second part of our arrangement. And Interestingly, if you look at our brackets, the parts show up in our brackets. We have 2 little x's in this part. We have 2 at the end of one bracket. We have 5 x's at the end of this part. We have 5 at the end of that bracket. And that's going to be important information when we move on to doing these questions without drawing the question, without drawing the tiles. The parts themselves show up in the end of the bracket. So turn to the next page. We're going to do this next question without using algebra tiles. First of all, you need to remember the word factor means that you are going to take the question and you are going to write it with 2 sets of brackets with stuff inside. That stuff is going to represent the length and the width of the rectangle of the tiles if we actually drew them. Here's some steps over here. So if you find yourself getting lost, you just follow through the steps. For this question, I've kind of given you some blanks to fill in. But this is the format you want to do for every single one of these questions. Step number 1, identify A, B, and C. A is 1, B is 5, and C is 6. It's important that we picture the tiles kind of and try and figure out the parts, the x parts. How many x's would go on one side of the x squared tile? How many x would go on the other side? And that's called part 1 and part 2. The first part of x's, the second part of x's. And we want to be able to find this so that algebraically, over here, we were actually just looking for 2 numbers. And those 2 numbers always, in this section, are going to multiply to be whatever C is. Now what is C? C is 6. So we are looking for 2 numbers in the world that multiply to be 6. Oops, multiply to be 6. That's down here. And add to be 5. This should be the other way around. I think your paper is the other way around. Let's switch this here. Let's make this the times, and let's make this the plus. We want them to multiply to be 6 and add to be 5. Now take a look. What numbers in the world multiply to be 6? I'm going to make a little list on the side here. Well, 1 times 6, 2 times 3. That's all I can think of. Either one of these two, do they add to be 5? Well, 1 and 6 is 7, which is not 5. But 2 and 3 is 5. So the numbers we want to look for are 2 and 3, and they're both pluses, right? And 2 and 3. Interestingly enough, that means if I was to use my algebra tiles, that I would have my x squared here, and in one part I would have 2 x's, and the other part I would have 3 x's. That's what the 2 and 3 really mean. But we also know that those 2 parts show up at the end of our brackets. So what are our brackets going to be? Even imagining we hadn't drawn this. Well, at the front of each bracket, we're going to have an x. And at the end of each bracket, we're going to have our parts. And our first part number is a plus 2. And our second part number is a plus 3. Now, draw tiles to confirm this answer. Well, I've started over here, actually. Let's fill in the rest. And again, you may need to pause this every now and again just to catch up. But do I have this diagram done correctly? X squared plus 5x plus 6. Let's repeat these steps for this next question. And we're asked to factor this. Step number 1 is always to identify what A is, what B is, and what C is. A is 1, B is 9, and C is 18. Your next step is to find 2 numbers that multiply to give you this guy, C, which is 18, and the same 2 numbers that add to give you 9. Now what multiplies to give you 18? Well, 1 times 18, 2 times 9, 3 times 6. You don't have to write these down, but it's kind of helpful to give you a head start. 18 plus 1 is not 9. 9 plus 2 is not 9, but 3 and 6 do add to be 9. So I'm going to put a 3 and a 6 and a 3 and a 6. And you should also indicate what the sign is for each of those. They're each a plus. That tells me that my factors, or my length and my width of my rectangle, will be x plus 3 and x plus 6. All right, the next one here. You'll notice that in this case here, the value of my c is negative, which is just going to add a little more algebraic work to my question. So let's begin again by identifying what a is, what b is, and what c is. A is 1, b is 3, and c is negative 10 because he owns that negative sign. I'm looking for two numbers in the world that multiply to be negative 10, and those same two numbers need to add to be whatever b is, which is 3. Now what multiplies by negative 10? You have to remember that if two numbers are going to multiply to be a negative 10, one of them is negative, one of them is positive. But let's just take a look here. So it could be 5 and 2, where one of them is negative. So negative 5 and 2, or 5 and negative 2, or 1 times 10. That's it. 1 is negative, 1 times negative 10. Which of these four guys add to be 3? It's going to be this one here. So 5 and negative 2 and 5 and negative 2. What are my brackets then? Or my factors? Or my length and my width of my rectangle? This is a plus 5 and a minus 2, a plus 5 and a minus 2, x plus 5 and x minus 2.